reality of the universe. Is this the real one? If we accept this, all motions should be regular respect to the center, or if we expect that mathematical one, we have to forget about this. This was the problem started right after Ptolemy, and even Ptolemy writing two different books. In one of them, which was Almagest, mathematical book, he didn't talk anything about the reality of the universe. And in this book, the planetary hypothesis, he didn't talk about the mathematical part. It shows that he really himself wasn't sure, 100% sure, what I have to say about the reality of the universe. Okay. Let's jump around 500-600 years, and then after Ptolemy, after the 2nd, 3rd century, we know that during the Roman Empire, there was no activities in astronomy, and after that we have this famous Dark Age, which was not completely dark. There were activities, but later, Muslims discovered these astronomical works. In fact, from 800 AD, they started to translate all Greek and Hellenistic works. They translated Ptolemy, Aristotle. Their language was not that efficient to translate highly philosophical texts like Aristotle's book, but they learned how to do that. And then, from 8th to 9th century, they translated Almagest almost 5 times. New editions. In fact, each generation discovered new things, and they didn't know anything about astronomy. In fact, in the first Muslims, they had a primitive folk astronomy, knowing some stars, but they didn't have any knowledge about these models, about these mathematics, and day by day they learned it from different sources, from Bundi Shapur, Iranian Sassanid sources, and then they learned from Byzantine, and then finally they found the sources from Greek texts, and they started translating all of them, and they produced, and then they learned a lot about astronomy. And most of these, it is another research we have to do, most of these happened in Persia, because they had a background, they had, in fact, patronage in Iran in Persia was so strong to pay money for these activities. Several observatories we built there. And then they started to criticize Ptolemy. Why? For 2 different reasons. First, Ptolemy was in 2nd century AD, and they started their astronomical works in 8th century AD, almost 600 years after that. Obviously, they had better instruments, and there are some variations in astronomical parameters. You have to adjust them in a critical way. So they found that they have to make new observations. At the same time, they learned about these major difficulties in Ptolemy's model. What is the reality of the universe? And they created a tradition which is called Hay'a, or the configuration of the universe. We call it Hay'at in Persian. Hay'a in Arabic, they tried to find out the reality of the universe. And a lot of astronomers try to produce new models. We know about Ibn al-Haytham, Ibn Sina's students, Abu Bayd Juzjani, Ibn Rushd, Ibn Bajjah, and many, many other people. These are some samples here. They try to create concentric motions. If the Earth is the center of the universe, we have to find out a mechanism to make all motions uniform respect to the Earth, not to the equator. So they had to modify to produce something, not a Ptolemaic model, a new model to make all motions concentric around the Earth. say 300-400 years after Muslims' introduction with, to Greek astronomy, we come to Marab Observatory here in Iran, Persia, built by Nasiruddin Tusi, Khaja Nasir Tusi, with a lot of money that Hulagu Khan spent to build and hire people. Nobody really knows how much money they put that. The 10% of the entire religious endowments in Iran went to build this observatory, to cast the instruments, and to pay for astronomers from all different parts of the Islamic world. And Hulagu was a good believer in astrology. He used it as a science of prediction. Today we send satellites to predict the situation, the atmospheric events, and at that time they really spent money to be able to predict the future based on, that was their satellites. And here, on top of this hill, here is the point that they built this observatory. They built a big observatory. This is the quadrant that they used for observations. Quadrant is something like this. This is the remnants of this quadrant. And this is the same thing that we see in Tycho Brahe's observatory. And here is the one that we had in Samarkand Observatory later. I'll talk about that. So Marab Observatory and Marab School was something like Harvard in 1250s in Persia. There were a lot of astronomers there, very, very able astronomers, and the top the chief astronomer was Nasiruddin Tusi, who was in service of Ismailis before the invasion of Hulagu, and he was very, very well-known astronomer and mathematician. In fact, when Hulagu went to come to invade Iran, his older brother asked him to send Tusi to China. He was that famous in China, but this, they sent students here to be educated at Marab school, and then he left, and an Iranian, in fact, as an astronomer, he went to China to educate them about new developments in astronomy. His name was Jamal ad-Din. In Chinese, they call it Jamal-Din. In Marab Observatory, a lot of astronomers, all of them involved in daily observations plus theoretical astronomy to make reforms in Ptolemy's model. A lot of names like Mu'ayyid-ad-Din Ordi, Ali ibn Umar al-Qazvini, Fakhruddin Aflaki, Fakhruddin al-Maraghi, Muhyiddin al-Maghribi, Qutb-ad-Din al-Shirazi, which is very famous, and he was the right hand of Tusi, Shamsuddin al-Shirwani, and others. They finally completed the Zij, or astronomical table, the first Persian astronomical, written in Farsi, because all previous astronomical tables were in Arabic, and they produced it in 1272. But at the same time, they were working on theoretical astronomy. Tusi wrote two very, very important books about his new model. One of them was Al-Risalat al-Mu'iniyya, and the other was At-Tazkira fi Ilm al-Hay'a, or Memoirs on Astronomy or Configuration of the Universe. There, Tusi invented an extraordinary mathematical device to make reform in Ptolemy's astronomy. It is called the Tusi couple, and this Tusi couple's role is this. We have an orb or circle, another circle or orb is inside it. The diameter of this is half of the diameter of the bigger one, and this little one rotates, the speed of this is twice as the speed of the